Hey everyone, we're going to plot each complex number in the complex plane and write it in polar form. And on this video, we're going to do two problems, very similar. The first one we're going to do is 1 plus I, and the second one we're going to do is -1 plus I. So in order to plot this, what I want to first do is find the polar coordinates so we can plot it. And we know that r equals the square root of x squared plus y squared. So in this case, remember there's a 1 here, this would be the square root of 1 squared plus 1 squared, which equals the square root of 2. Remember, r is the distance from the pole to the end. So it's like the radius or the amplitude. Next, we got to find theta, and theta we use tan, because tan of theta is y over x. So we have tan of theta is 1 over 1, which is 1. We know that tan of 45 degrees equals 1. So we have square root of 2, comma 45. And before I plot this, I'm going to go ahead and do this problem same way. We have r, we need our r and our angle, and so r is going to be square root of -1 squared plus 1 squared, which equals the square root of 2, and then tan of theta equals y over x, which in this case will be -1. So our angle is going to be 135 degrees. Therefore, that would be square root of 2, comma 135 degrees. Okay? Now, let's go ahead and plot this. We have, let's call this 1, and this 1. And the one we're doing here is our polar form is going to be z equals 1 plus I, and we got square root of 2 and 45 degrees. So 45 degrees is right halfway through. So here's your pole. You go up here, and there's your end. This is your imaginary axis, and this is your real axis. And then you just draw, you can just do this if you want. But there it is. And also we need to write it, express this in degrees. So we can also write this as z equals r, let me just write out this first, cosine of theta plus I sine of theta. In this case it would be square root of 2 cosine of 45 plus I times sine of 45. Okay, and the second one we had already done. We have the polar form is z equals -1 plus I. Our coordinates were square root of 2, comma 135. So we have -1 for the x. I'll call this -1 for your real part. Your imaginary part was 1. And we're going to go to 135, which is right about here. And the length from the pole to this is square root of 2. And then your angle here is like this. And then for our expressing it in degrees, we have z equals square root of 2 cosine of 135 plus I times sine of 135. And that's all. Thank you. Have a nice day. Bye-bye.